Ed Faison from Highstead. He'll be discussing a phenomenon around here, an increasing herbivore, a very large herbivore, and he'll be talking about assessing the changing effects of moose and deer browsing on forest ecosystems. Next.
Good morning, everybody. I want to start by stepping back to 1988 and the start of LTR1. And as many of you may know, deer fencing was built around each of the major experiments that were established that year to protect them from deer browsing. Moose were not even on the radar yet. They were just beginning to make their way back into the state after being extirpated for almost 200 years. So after a couple years of this fencing being up, and virtually no browsing was detected in any of the experiments, and they were eventually taken down because they were deemed unnecessary. And this was true even for this hurricane simulation experiment that Audrey will talk about shortly, where obviously you had a large canopy disturbance and a flush of new growth in the understory, which is typically a magnet for large herbivores such as deer and moose if they're in the area. Now, moving forward to LTR4, today we find ourselves in a much different scenario with respect to large herbivores. As you can see from this picture, moose are now very well established on the landscape and are responding vigorously to a large canopy disturbance, as well as deer are responding as well. And this is the Locust Opening Road patch cut harvest here at the Harvard Forest. And we know from other studies in the boreal forest and in other parts of the temperate forest that moose and deer at high densities can have large effects on forest ecosystems. Selective browsing by moose has sped up forest succession, has altered soil nutrient dynamics in parts of the boreal forest, and has caused sharp declines in major tree species. And one example of this is balsam fir on Isle Royale. Fir once made up about 45% of the canopy in the mid-19th century there. It has declined to about 5% of the canopy by the late 20th century, and this is attributed primarily to moose browsing by Rolf Peterson. Deer, of course, have also caused sharp declines in important trees such as eastern hemlock, particularly in the Great Lakes States region. Deer being grazers as well as browsers, meaning that a large proportion of their diet is herbaceous as well as woody, have had important effects on forest herbs as well, such as the rare American ginseng in the Central Appalachians. In the Northeast here in particular, selective grazing and browsing by deer, native species has increased certain invasive exotics, including Japanese barberry pictured here, as well as garlic mustard. So at the start of LTR4, we knew that deer and moose were potentially important drivers of forest ecosystems. What we didn't know was how moose were going to affect a temperate forest system that they had just returned to, and how moose and deer browsing were going to interact together to shape this system. So a couple of years ago, at the start of LTR4, my collaborator Steve DiStefano and his research group from the Massachusetts Cooperative Fish and Wildlife Unit approached the Harvard Forest about a project that they were initiating, an exposure experiment that they were initiating in the Quabbin and Ware River watershed forests. And this coincided with an initiative at the Harvard Forest to log several of our old red pine plantations to promote the growth of native trees. And thus was born a opportunistic and fruitful collaboration between the two research groups that is extended to include state watershed and wildlife agencies here in Massachusetts, as well as forestry and ecology groups down in Connecticut, including Highstead, where I'm from. We've expanded our scope to begin to include unharvested forests, particularly down in southwestern Connecticut, where harvesting is pretty non-existent and deer densities are quite high. And we also continue to think about how to link our browsing studies with animal movement projects, both within our own research group as well as with the Paul Moorcroft group in Cambridge. So we've established 9 exposure sites across southern New England, including 4 at the Harvard Forest, 3 at Massachusetts State Watershed lands, Quabbin and Ware River, and 1 each at the Great Mountain Forest in Norfolk and the Yale Myers Forest in Union. Connecticut. And these Connecticut sites are really the southern range limit for moose in southern New England, and thus give us a pretty broad range of variation in moose densities and site conditions across our study area. Our design includes 3 treatments: a full exclosure that excludes both moose and deer, a partial exclosure that excludes moose but not deer. There's a 2-foot gap at the bottom of the fence that allows deer to crawl under, and then an open control plot. And this design is somewhat unusual for exclosure experiments. Most experiments typically just have a full exclosure and a control. And what our design gives us is an intermediate browsing intensity treatment. That was the hope anyway as we began the project. And it also allows us at some level to compare the effects of deer browsing alone to deer and moose browsing together. And so a major question when we began this project is, would the design actually work? Would deer actually bother to crawl under a fence when they had abundant food outside the fence that they could eat and didn't have to work for at all? And the answer is yes. They almost immediately did begin using the partial exclosure, and this is a deer in the Great Mountain Forest partial exclosure, just not long after the fences were built. We've also seen other animals, bear, coyote, bobcat, wild turkey, have all passed readily through this partial treatment. And the only animal we're not seeing in there is the moose, which of course is what we were hoping to exclude. And we've also found that the partial exposure is in fact giving us a pretty good intermediate browsing browsing intensity. About 30% of hardwood stems were browsed this past year in the partial exposure versus about 70% in the control plot. And so after a couple of years, only a couple of years, we've already begun to see some interesting results at our sites. These are data from our 5 oldest sites that were established in the winter, spring of 2008. And as you can see, a greater number of stems have recruited above 1 meter in the full exposure than in the control plot. The partial exposure is not significantly different from the other treatments. But it does seem to be behaving more similarly to the full exposure, perhaps, than the control, which is interesting. And with respect to tree species richness, again, in the full exposure, a greater number of stems have recruited above 1 meter. A greater number of species have recruited above 1 meter. And in this case, more than both the partial exposure and the control. So in this case, the partial exposure seems to be behaving more similarly to the control. And I guess what this seems to suggest is that a low to moderate browsing pressure of, in this case, 30% browsing intensity may be enough to cause some important declines in species richness, at least in these early stages. Now, with respect to sort of broader compositional changes from browsing, we've found that moose and deer are browsing hardwoods rather indiscriminately, very intensively, but they're largely avoiding white pine. And white pine only occurs at 2 of our sites, so these data are only from those 2 sites. There's no significant difference, but you can see there seems to be an interesting trend developing of an increase in relative abundance of white pine above 1 meter in the control compared to the 2 exposure treatments. And you may not be able to see this in the back of the room, but these pictures very clearly, but these comparative photos of the full exposure shows a very dense plot of hardwood regeneration with a few scattered pines, but it's very hardwood dominated. Out in the control, it's much more sparsely vegetated, very intensively browsed, cropback, red maple sprouts, and a greater proportion of white pine making up the seedling component. Another interesting thing about our data we found is that although browsing has been a very important control of large tree seedling density and richness above 1 meter, in the smaller size classes, browsing has been much less important, and not very important at all, actually. And in this 30 to 99 centimeter size class, we found that site conditions, in this case because we looked at the size of the clear cut, was a much better predictor of seedling density and richness than than the actual browsers. This is the locust opening road patch cut here at Harbor Forest, and this is a smaller cut in the Quabbin. And this may be explained by just the foraging height preferences of the two browsers. Moose typically forage at 1.5 to 2, or forage most of their foraging is about 1.5 to 2 meters off the ground, whereas deer are foraging most often at about 1 meter off the ground or a little bit less. So they're definitely going to be hitting these larger seedlings more heavily than the smaller ones. So to summarize, browsing is very important. It's a very important control of larger tree seedling regeneration, much less so in the smaller size classes. Hardwoods are being browsed quite heavily by both herbivores and rather indiscriminately in both the partial and the control. But white pine is being largely avoided and may be increasing at some of our sites. I didn't speak about this one yet, but in our studies of the effects of high deer densities in unharvested forests in southwestern Connecticut, we're seeing that deer are having an important effect on oak regeneration. So as we move forward, we'll continue to be interested in this question of whether selective browsing by hardwoods leads to an increase in white pine abundance. And this has important implications for ecosystem processes in the region, and also has some interesting potential parallels with the boreal forest system. Moose, as I mentioned earlier, selectively browsed hardwoods and led to an increase, which has led to an increase in spruce. And so we may have a parallel situation down here where a major conifer increases. Also interested in this idea of if intensive browsing is reducing the density of regenerating stands, will it increase the growth and yield of the remaining trees in these stands? And this obviously has important implications for forestry operations. We want to continue to examine the response of vegetation to different browsing intensities. Does vegetation respond in a simple linear way, or are there more complex responses by the vegetation? Does a certain browsing threshold have to be reached before we start to see changes in certain vegetation? So we'll be building 6 new exposure sites across our study area, mostly in unharvested forests, but also in partially harvested sites. And this will give us a range of canopy disturbance from complete removal to undisturbed, in which to examine the effects of browsers. And we also want to look at the interactions of forest fragmentation and deer activity and impacts, particularly down in southern Connecticut, where deer densities are quite high and fragmentation is prominent. And we want to continue to examine the effects of browsing on foundation species such as hemlock, which has obvious links with Aaron's work, and as well as Jonathan Thompson's work with future scenarios, which he'll talk about later. So that's all I have for now. Thanks very much.
We have a couple minutes for questions. I want to ask you one. Have you actually seen moose in those Connecticut sites yet?
They were just built, so we haven't seen the sign yet, but they are down there. People at those forests have seen them.
How much, given what you're seeing in your control plots here at Harbor Forest, do you think we should be paying a lot more attention, or about the same amount of attention to browsing activity or other long-term experimental monitoring plots?
I would say in areas where particularly where there's some sort of a canopy disturbance. I mean, I think of the chronic N plots where I've seen some heavy moose browsing, and I'm sure the people who work on those have seen that as well. I'm not as familiar, I haven't gone out to all these experiments, so it's hard to know how much browsing has happened. Certainly, moose are really focusing on the cuts. You don't see moose sign as much in the undisturbed forest yet. Maybe that'll change as they become more common in the landscape, but the intact forests are hit more often by deer than moose these days, except for the areas right around the cuts.
Just to sort of follow up, it's an interesting interaction there between the hemlock and delta, agent disturbance and mortality, and then the deer and the moose as agents of suppressing regeneration. That just seems like a really interesting avenue to pursue.
Yeah, absolutely. Thank you very much, Ed. And I see a lot